Welcome to Season 7 of the Prosthetics and Orthotics Podcast. This is where we chat with experts in the field, patients who use these devices, physical therapists, and the vendors who make it all happen. Our goal? To share stories, tips, and insights that ultimately help our patients get the best possible outcomes. Tune in and join the conversation. We are thrilled you are here and hope it is the highlight of your day.
Hi everyone, my name is Joris Puels, and this is another episode of the Prosthetics and Orthotics Podcast with Brent Wright. How you doing, Brent?
Hey, Joris. Doing well, man. I'm pretty excited about today's podcast, but before we get into that, I was actually talking with somebody, and they said, I love the podcast, Joris. You do, having the combination of Joris in Spain and then Brent, obviously, here in the U.S., and the question always comes up, like, what are you guys doing and how'd you meet? So you want to take a stab at that, and then I'll kind of give my color commentary.
No, I think we just ended up, well, I was following you actually because on LinkedIn you were doing really interesting things with MJF, and I do a lot of stuff with MJF as well. And I'm just curious about all aspects of this 3D printing realm. And I love the way that you were teaching people and you were always explaining stuff, and you spent so much of your time trying to help people. And then we really connected. I wanted you on my other podcast. It's like the 3D Pod with Max Vogue. And so we had you on there. We really connected over that. I really connected over your Life Enabled, the nonprofit stuff. And I was just like, we should maybe talk some more about this. And then we kind of really hit it off. I think that's a real key thing. Key element, really.
Yeah, I mean, so like, and then from my perspective, yeah, I mean, being on the 3D Pod was amazing with you and Max, and it was just great questions and such. And then we kind of kept up, and you would kind of poke and prod me sometimes as far as why are you doing that, really trying to learn the stuff. And then we started talking more and more, and then I was like, you know what? I think this podcast thing, there might be something to it. Let's try an O&P one. I would say, I mean, you were kind of a little bit hesitant, but I mean, you're like, yeah, let's do it. And now, we've recorded over 70 episodes.
Mm-hmm. And my expectations were just like, okay, I'm going to enjoy talking to Brent. And I just didn't know if this kind of like, you know what? I thought it was going to be really stuffy because I thought this O&P was kind of stuffy. I didn't go out and tell that because I know that this is like your life's passion and everything. It's like, your life's passion sucks. It's not a great conversation story, right? But I really, so I didn't expect that it would be so hands-on and technical challenges and people engineering and arting their way to a better functionality of another human being. I really missed how challenging and cool that was. And I also really didn't appreciate just how completely crazy like everyone's career path is in getting this, and how like really diverse everyone is. There's so many different people, so many different backgrounds, and all were just like, nobody's like some people are like, my dad was a prosthetist kind of thing, and other people were like kind of randomly walking in the wrong classroom. and so there's so many backgrounds and stuff. I really think that people are much more fascinating than I thought I would initially. And also I think we did realize at one point that this whole digitization thing is actually really important. I mean, we could do a similar podcast, I think, for dental, aviation, news space, medical, right? But there's not that many other areas, Like in automotive, we kind of run out of, we talk a lot in circles, but there's so much going on in O&P, like good and bad. So I think that keeps this really relevant all the time.
Well, and I think like you're on the cutting edge of stuff like that isn't even coming out, and I think that's what I appreciate from you is, you have this kind of vast knowledge and experience of over a period of time what additive manufacturing has done, and that means a lot to me as far as I'm not as versed in that side of things, and on the business side of things, acquisitions, mergers, the story behind the story, right? So there's the story, and then there's what's really going on. So I think that's also important context for our listeners as well. So I think, even when we do the stories about acquisitions and such in the O&P market, your takes on that are very valuable because you're seeing this on a daily basis in the additive manufacturing space, and we're just kind of like a small player in that. So I think we have great conversation, and it's a lot of fun.
Totally, dude. But that's key. I really look forward to this always, and so I'm always like, oh, this is an awesome part of my week, So I think that it's wonderful. And then the fact that people like this is super secondary, but it's nice as well, I guess. It's nice. And it was really surreal when people started like, we want to sponsor you, and I'm like, oh, okay, if you want to.
Yeah.
So it's like we're you're sponsoring, talking to a friend,
So speaking of sponsors, Joris, we've got a sponsor, right?
So we have a sponsor for this episode. They're Vorum, and Vorum makes a lot of software and tools and kind of end-to-end solution. It also connects with a lot of external tools that aren't theirs to kind of tie your workflow from scan to print or scan to carve all together. And they've got a thing called CanFit, right?
Yeah, so CanFit's been around for a while, and I would say one of the neat things about what they do is they allow the clinicians to be the clinicians. And what that means is if there's a specific flow that you do for making a prosthesis or an orthosis, you can actually automate that flow. So let's say if you're making a solid ankle AFO, all your buildups automatically come in, trim lines come in, and then you're ready to rock and roll. So it saves a lot of time, so you don't have to do that every single time. And the same happens with the prosthesis. And so I think that is, really a benefit of CanFit.
Okay, that's cool. And if we're looking at an AFO, like how much time does that actually save you? I mean, your mileage may vary, obviously, but can you give like an estimate about how much that would save a clinician around about?
Yeah, so if you're making this every single time, I mean, you're probably looking at 15, 20 minutes, potentially even more. But, once you do this kind of automated flow, it really happens pretty quick, probably 5 minutes or under. Which is pretty amazing, but a lot of that is just computation time too. So, the actual computation time is very, very small, but it's all that goes into it. So, one thing that I'm a little bit sensitive to is, this, and what I love that they don't do is they don't say, hey, we save you all this time. It's really, how do we leverage what to create a workflow that's consistent every single time? And yes, in the end, it will save you time, but that's not one of the main points that Vorum's trying to make.
It's a different approach. I think a really mature approach, and I think that could be very, very helpful in people getting it right, not the first time, but every single time. Thanks a lot to Vorum for sponsoring us.
We have a long-suffering guest somewhere who's been waiting for us.
I'm sorry, Justin. We get carried away sometimes.
Who's joining us today?
Yeah, so this is going to be a fun one. Not only for me but for you as well. Justin Hopkins is joining us. He is actually the application engineer for HP and the multi-jet fusion stuff. And so, what's neat about Justin and I have known each other for a long time, and he's been such an encouragement, not only to me, but also to our nonprofit organization, really seeing how the prosthetic industry, but then the prosthetic industry can use multi-jet fusion and digitization in general. And, he's pushed me into, some of the materials side of things. He's definitely helped me out. And then he just has a heart for scaling this in an international space to where I believe we have the same heartbeat, in the sense that we want to see people worldwide that want a prosthesis, get a prosthesis due to specifically multi-jet fusion. But, because multi-jet fusion machines are everywhere in the world, and so from their kind of local contract manufacturer, essentially. So I'm really excited to hear kind of his journey and what's got him here, but then also hear some insights into the orthotic and prosthetic industry from the OEM side of things.
Yeah, totally. This sounds really good. So welcome to the show today, Justin.
Thanks for having me, guys. It'll be fun, and I'm very excited to be here.
Okay, cool. So first of all, our question is always like the first question is always, how did you get started with OMP? So you said, how did you end up in this field or doing this as one of the things that you do?
Yeah, so it's been quite the journey for me specifically and the team itself over at HP and the application engineering side. It kind of goes back about 4 years ago. I believe we met Brent. I wasn't actually at the AOPA in California, but at that time I had a manager named David Pierk, and he wanted to attend that show, and I think we had a small booth, and that's where the relationship started between HP and Brent. And from there, um, as we started to be driven by David Pierk in application development, we were all kind of assigned or got to choose what type of segment or application that we wanted to dive into. And for me, what had actually started that off was we had a employee on the site where I'm at in Atlanta. The facility is actually in Alpharetta, Georgia. And one of the gentlemen contacted me and said, "Hey, we have a person here that would be interested in seeing if there's a possibility to print a prosthetic." And so we had several conversations, and started to reach out and start to think, how can we make this happen? Right at this point, I personally didn't have much knowledge in the applications. It was more of a desire to want to work with somebody. Right? It's like, oh, this seems like a good opportunity to help someone, in addition to learning a new skill. Right? And so we had several conversations, and in the end, it didn't work out. So when David approached me and said, "Hey, what segment or application would you like to work in?" I chose orthotics and prosthetics. And this was at a time right before COVID. So I started to do a little bit of research, and then COVID happened. So then I actually had lots of time to dive even further into what was going on with orthotics and prosthetics. In the meantime, we had already kind of started that relationship with Brent. He came out to San Diego where we had an application engineering summit, and that included our entire team with HP. And we saw a session with Brent doing a live scan. And then in addition to that, part of the software workflow, right? And so when I had a larger amount of time during COVID, I spent a lot of time researching what is the first step for us to even play in this field, right? And the first step was looking at the software side of it, right? And if we can't get individuals to a point where they can provide a file to a machine, we're going nowhere, right? Despite the fact of where we might need to go after we're able to get something printable. Is it going to work? Is it going to survive? But the first steps were sort of outlining what the workflow could be like if we had these conversations with different individuals. And the one thing that was always a good reminder to us is when I was encouraged to kind of start working in this particular area was, we're not doing this to make money. We were trying to do this to help people. We thought it was the right thing to do, right? Despite the fact with any sort of application development, you learn lots of different skills along the way that could be used within other industries. And so from there, I joined with, at this point, I was just a regular application engineer on the team. And I joined with another gentleman named Justin Hopkins. And we put together divide and conquer, right? I would focus on software. We would connect with different clinics and practices to form a webinar series about information with 3D printing along with orthotics and prosthetics. And so we ended up releasing about a 4-series webinar on workflow, software, scanning, business side of it. We had different clinics on. We had Brent on. We had a couple of other guests there from different areas like Quorum. And it just kind of started to work from there. And what we started to see from our side was, we started to see a little bit of growth inside of the area of people adopting additive within the industry. In addition to that, along with that is that you start to see a little bit of sales go up, right? And so it's like this works well for both. Like we feel good about what we're doing in the industry, along with the fact that we're occasionally selling some equipment or even services throughout that that is beneficial to the company, along with the personal sentiment with being involved in the field. Throughout that, over the last couple of years, then it's sort of gone. I've kind of stepped away, and now I'm the manager of the application engineering team. And we've dedicated different application engineers within the industry to focus more on it. So now it's more of like, where do we want to go as far as like testing different devices? Because once you get people to sort of adopt a workflow and get into printing, now you're in this position of, is it comparable to what already exists? Can we eliminate some fear that might happen with adopting the technology? And I think that's kind of where we are now, right? We're getting some people to adopt the technology within the field. And now there's more work to be done on proving out safety of the devices that can be printed, how they should be printed, and trying to put some sort of formation around the proper way to do that.
Okay. And just a little bit for people who are watching, like, okay, we talk very freely about application development, application engineering. Is one of these things that doesn't exactly mean the same thing to everyone. As far as you're concerned, what's application engineering? What is the goal, or what are you actually doing when you do that?
So within the realm of additive or 3D printing at an OEM, an application engineer is pre-sales, and then they also have a role on the back end of what we would refer to as post-sales. And so if we look at it on the pre-sales side of it, is that we're divided into teams. And so there is always a sales representative that's a territory, and then there's an application engineer. And so what an application engineer in general will do is meet with an opportunity or a customer to work through what is the application, what is the interest within the technology that you're offering, right? What is the problem that the customer is trying to solve, whether it be a workflow, whether it be a device improvement, or actually translating something from traditional manufacturing, whether it be CNC or injection molding, to an additive process. So your application engineer will work with the technical side, but they also have to speak to like CEOs and other financial representatives within a company to lay out what the business case might be, in addition to what is the problem that you're solving and how do you implement that technology with the application that you're trying to print within an industry or a company. After the customer has a piece of equipment, they may need assistance on improving, printability of that part. So there may be some part quality. So we play the role of proving out a benchmark. So let's say Brent comes to me and wants to purchase a machine, and he wants to print a below-the-knee prosthetic. One, I need to understand what the device is, what the application is, what is the best way to print that, what is the ROI of printing that device. Is there one? Is it break even? Or is there some sort of added value that maybe it costs more to print the part, but you're adding in a value that can't be defined by a dollar value within the application of being printed as opposed to being traditionally manufactured. On the post-sale side of it, so it's more of a workflow. It's workflow improvement. Because you could have a service case with a system that has nothing to do with the machine itself. It may have something to do with the file itself. The file could be corrupt, or maybe it wasn't designed properly to work for additive manufacturing. So you kind of work on both sides. In addition to that, if there's feedback from a customer, we're kind of the go-to where we can feedback information to R&D. So as we develop more equipment, you're getting that customer input directly to the team to translate into R&D.
Okay. That sounds really great. And I think, but the secret sauce is, of course, is that often people, you don't know what they don't know. And they don't know what you don't know. And they don't know what the technology can do. But what they think the technology can do is based upon wildly crazy assumptions and things I've seen on like Nightline or whatever. And so so there's this translation part, right, between, and often sometimes somebody's a business person, they don't understand the engineering. The other time you're talking to some material scientist who understands, she has a vocabulary, but it might not be the mechanical engineer. So you're often really translating, and often that can go really wrong. I mean, to me, the secret sauce is like about that translating between these different groups and different populations with different skill levels and different levels of additive understanding. I mean, that to me is the secret sauce of this application development stuff.
Yeah, so it definitely is. It's about an education, right? And it's about, like you just said, translating what the needs are of the individual that you're either selling to or developing the knowledge within the technology. Two different organizations inside of the company that you work for, right? There's a difference in between talking to an engineer and a salesperson, right? We play the role on the sales side, but typically we're more focused on making an application work for the individual.
Okay, I think that's good. And then, yeah, I'm sorry, go on.
I was going to say, you mentioned application development, and application development is within that role, right? And application development is a whole host of different things that an application engineer will do. If it's, it could be finishing, it could be textures, it could be, lattice structures, it could be a whole host of different things within developing a specific application, or an application that's going to go into several different types of applications. So once again, it could be post-processing, it could be software, it could be a lot of different things. It's about increasing the success of whatever the product might be.
Okay, that's cool. And then I think one other thing that I think is really delicate is like, you could have a client come to you and say, I absolutely want to print this thing, and it could be completely the wrong thing, right? and it could never work. How do you tell people these kind of things, or do you then kind of pivot or try to get them to, to kind of focus on something else or another value, or when do you decide like this is not going to work?
Yeah, I mean, I think it's part of our role to see that vision. Is it possible? Sometimes you have to ask that question, and we as the application engineer might not know the answer if it can be done, and that's where we have to take those risks to see if it can be done, right? Because sometimes you don't know until you try, and so there are definitely times where you will go in and you'll be like, all right, this is not going to work, but your job is to look at it and say, is there a way for this to work? But you also can't get so personally attached to an idea that you can't walk away from it, right? Because there are certain times where you're like, this isn't going to work, and I need to step away and say that this is not going to work. And a lot of times it may be you look at something and say, okay, it's not going to work in the way that it is now, right? If we make this change or that change, then it has a potential to be printed, right, or be successful with additive. So you kind of have to holistically look at what the application is, and your job is to be honest. I feel like the application engineer is there to say, I don't think this is going to work, and these are the reasons why.
So, and then in the orthotic and prosthetic realm, in the orthotic and prosthetic realm, when you're doing these, talks and such with, say, clinicians or even companies, what are some of the big things that you look for as an application engineer to kind of move them down the journey into not only digitization, but then obviously looking at the technology of multi-jet fusion?
I think the first step is to look at the size of the clinic, right? Is this a clinic that, is going to spend a vast amount of money to do this? It could be extremely beneficial to own your own equipment because you can control the input and the output of what's happening. But then if that's not the case, it's looking at, what is the best partner to send them to that can provide them the quality part that they need, right? So it's making those connections with the, we could use the term service bureau or contract manufacturer, a company that has several pieces of equipment that will produce parts. And with that being said, it's a very sensitive field that you can't just necessarily, you don't want to just throw the part out there, right? Because there are certain things that may need to be done with printing an orthotic or prosthetic device that, a standard process through a service bureau, it may not be as effective, right? And so, you have to look at what are they trying to achieve as far as on the output? Do they need a lot of parts? Do they have enough devices to warrant a piece of equipment? Or do they just want to try it? That may be within an internal benchmark within HP, or it may be connecting them with the proper partner. As far as the side of, are they capable of making the file, right? And that would be one of the first questions. Like, what is your workflow right now? Are you just using plaster? Are you scanning? If you are scanning, okay, that's our first checkbox, right? So you have a digital file, but what are you doing with the digital file from there? What software are you using? And depending on the desire of how far they want to take the design of that particular device, it may be, sending them to you, Brent, right? Where they can get, vast amounts of knowledge and design skills within the field, or maybe they need a clean and simple design that can be achieved through a software that's already available.
Okay, that sounds really exciting. And where do you see the opportunities in if you're just not looking at 3D printing plus orthotics and prosthetics? Where are you like, oh my God, that's so exciting, that area we need to explore? Maybe it's not happening right now, but where do you really see the opportunity in the future?
Yeah, for me, I mean the flexible materials, right? The elastomeric materials that are being produced is just starting to harness what I feel like can be done, right? Just from the fact of what can be implemented into the device, right? And seeing the different designs that have come out. Is it just like a sleeve, or is it being added as cushioning? Are we using lattice structures? And there's been a lot of work done on our side to evaluate what structures work with different materials. What type of foam can we simulate with lattice structures? Is there enough space or thickness within the device to actually take advantage of using a lattice structure, right? There's a lot of ins and outs of, okay, I can put a lattice structure on it. I've seen some orthotics that had some, you could call it a perforation or a lattice structure, but they're so thin they're actually, putting the device in a situation where it's not really taking advantage of the lattice structure. It's more of an aesthetic purpose as opposed to a functional purpose. So I think with the materials that we currently have available, development within more of the elastomers is an exciting part to see, whether it's with a socket device or we're seeing more movement in cranial orthosis devices where the softer materials are playing a bigger role within those devices.
It's interesting that, okay, well, first off, like one of the areas where additive really plays well is in this personalization. Do you see that? Well, on one hand, that really has benefits, right? That we can optimize this lattice for a person, or we can size something for a person. Are you seeing a lot of traction there as well, that people really understand that, like, wait, we can change this for Joe, and then we can make a different one for Jane?
I think the concept of doing that is translates very well, and people understand it. The ability to design those files isn't as easy as it should be, right? So I think when you ask, where I see the most movement, I think it's going to be more on the software side or specific applications to a person. On the software side, can we design a tool for this particular clinic that wants to do this to the device, right? One thing I feel like I've learned is there's no one size fits all piece of software within your field, right? You almost need 3 or 4 different things. It depends on the device, and it seems like very segmented in the sense of, like, you may have a software that does really good insoles, or you might have one that works well with prosthetic sockets, but there's not necessarily one that kind of does all of it. And I don't think that that's a bad thing. it can be more costly because of the different pieces that you kind of have to get. So I think developing tools that make it easier is something that needs to expand, and I think that's where we'll see more improvement. So you can take advantage more of the personalization that you're speaking about.
Okay, and then what I think, and I'm glad you asked that, because that's literally kind of what I would say. And then on the other side, I would say, like, but where the value is really right now, I think that there's much more inaccessible values in designing a particular, like, I call it a material, but it's essentially designing for Joe and his leg, defining a really, really unique material, or to design a unique material, if you will, or a unique part that is really the best part for that particular human prosthetic interface. So really, that those changing the part properties of the device. I think that's something to me that less people are talking about, but I'm much more excited about.
Yeah, I think, along the lines of that software side of it is how do we simulate that, right? I mean, our team has a strong interest in, can we take the FEA analysis and predict maybe where a device might fail, or where can we improve it from the feedback that we're getting from simulating it, right? Because the more advancements we can get on the simulation side of it, the faster and better devices that can be produced, in the sense of, we can run it through and say, okay, this might be a problem. And I think that's, when you get into a digitalization of producing parts, you have to kind of take advantage of that, because there will always be this question of will it fail? How will it fail? And the more work that we can do on the side of predictiveness of that, I think the better off we will be.
So yeah, around the software on some of the stuff on the lattice structures, I'm just kind of curious, there's, and you scroll through social media feeds, or even like the LinkedIn stuff, or you go to these DFAM meetings and everybody's talking, is it stochastic lattice? Is it an engineered lattice? Can you take our listeners through what these people are talking about when you're talking about lattice structures, and maybe the pros and cons of each of them?
So you could probably talk for 45 minutes about the definitions of it, and I don't think it won't go over any well or better than what you were just stating, right? But the main thing to think about the lattice structures, at least with the materials that we have, are what are the requirements to make a successful lattice, and part of that would be that you don't want you want one that will vary in size, so it ends nicely with the nodes at the end of, or wherever it's going to end, to be attached to the surface of the part, right? You don't want these broken structures throughout your lattices. Selecting different types of lattices has to be evaluated, right? And when you get into elastomeric materials, you can spend a lot of time evaluating the responsiveness of those. And so on our professional services side of HP, we have an entire group that's dedicated to lattices, and they've created a library of different ones with different materials that have different responses, and that's where it makes it a little bit easier. Is how can we you do need to have some understanding of what the lattice structures can do. But do you need to know all of the definitions of where they, as you had mentioned, like the scholastic and the random, and do you necessarily need to know that? I think going along the lines of simplicity is making that information available, right? Where you can select the particular one to get the output that you're looking for. Does each individual need to be an expert in the definitions of what the lattices are? No, but they need to know the end result of what that particular lattice structure design will do for the device that they're going to use. And I think that's where we will start to play a role, and you'll see other companies like Carbon start to make that information more accessible and easier to be utilized, right? And that's where it needs to be for the regular designer, right? What am I trying to accomplish with that? You may need to know like the shore value of what you're trying to achieve, And that can be translated with, okay, if I have a library of different visuals of those lattices, selecting that one with the thickness of the device, and then it telling you what shore value that you will hit.
Okay, I think that's really interesting because like lattice is like this magic, right? But not a lot of people understand it. But the other thing is, why I'm always really hesitant using lattices because it's very difficult to model their behavior, especially like with like really big impacts and stuff like that. And that's super relevant, of course, with prosthetics and stuff. And so these long-term impacts or repeated impacts and rebound and all that, it's often very difficult as an engineer or something to understand what that can do or what kind of tweaking that design can do. So are there alternatives? How can I, understand that better, or how can I understand that performance better? Or is it just so mystical that you guys have some special guys that can do that, but like other people can't do that?
I think it takes a lot of testing, right? I don't think there's you have to define it through mechanical testing. Once you have that information, then you can start to model out what the responsiveness might be. But you essentially, in a basic term, you have to print the coupons. You have to do the mechanical tests to see, after X amount of pressure and how many cycles we're actually doing, does the material start to break down, right? And that will be dependent on the lattice structure that you choose, the diameter of the nodes that are inside of the lattice structure, lots of different, it's like endless possibilities, right? So that's why creating a library makes it more accessible and easier, right? Because we could go on forever with different structures that could be designed and created. So defining ones that are known, and like I said, that's doing through mechanical testing. And once you get enough statistical data proving out, the longevity of that particular structure and material, and that's the thing is, if we start with one TPU and then you switch it to a different TPA and you're using the same structure, you'll get a different response, right? And so there's a lot of characterization. It's not that I don't think everyone could do it. It's just a large investment of time. And so, once again, trying to make it more accessible for the use of everyone is more the key.
And how do I get you guys to help me with that? Do I have to come to you and like pretend to buy a couple of machines, and then at the last minute decide not to? Or
No, absolutely not. So the one thing with us, it's been a little over a year since we launched the professional services side. We within that team, Peter Kaiser leads what we call our design services, and so we have about I believe he has like 5 or 6 people on his team, and they the way we approach that is let's say you came to me and said I want a TPU and I'm trying to emulate this type of foam with this particular device. So you may have the initial conversation with me, and then we'll gather our team. So we have one person that writes the contract. So you explain the outcome of what you want to happen, and so any sort of contract that was written is specific to that outcome, right? It's like my device is going to do this, and it's very clear. And then we engage with our design services team where they may be printing samples, right? So we've done some projects where we were emulating foam within helmets for sports. And so, or even seats for different agricultural pieces of equipment. They just sent us the foam. We tested the foam. And it's like, all right, we can match it with this coupon. We send the coupon back. Once they approved the response of the coupon, then we can do the design services within. It's like, here's our shape of our seat that we want to do, or the device that you're trying to do. And then we can populate the proper lattice structure inside that design. Or you could even have a custom tool designed for your purposes, right? So if you said you wanted for us to create a script or even a tool for you to use to create padding within a prosthetic socket, we could do that, right? So we could make the the tool that you would use to where once you scan that person, you input that value in, and then it can output the part that you need for that particular part. So it's really easy to work with us. I mean, you can engage with anyone on the HP 3D side, whether it was metals or plastics, and we can utilize within our team those services. And it will be project by project. So there's no, sometimes you get a question. It's like, well, what are the services? The services are designed to fit whatever the customer needs.
Okay, that's super cool. And then one thing that's really exciting about these lattices, and especially with these TPUs, CPAs, stuff like this, is this idea you can optimize the design not just for kind of a uniform response to anything, but like, for example, the example I always use is the helmet. Like, you can optimize the helmet to work the best at slow, really, really heavy impacts and really sharp, really fast impacts. And I could see that in orthotics and prosthetics, that kind of thing could be really exciting too, that you really can optimize one part for the most irksome or the most annoying or the most debilitating impacts, right?
Absolutely. I mean, you could have different zones for different responses, right? Like you said, you could have a softer zone that's going to receive more impact, or you could have one that's going to respond and be stiffer. That, unlike on some sporting goods, you may want that structure to crush, right? So you're going to design for failure, but you want it to fail in a specific way. And so you have to define at the beginning of what the goal is, and everything can be designed to create that response. The downside to that is who is the first person to do it? They're going to absorb all of that expense, right? And going through all of that. And as more and more tools become available, it's like with anything, when you ask a customer, what do you want to see more in 3D printing hardware? That they're always going to say cheaper materials, more materials, right? It's the same thing when you're talking about like software. You always want it cheaper and faster. And so, it's always a long road. And I think the beginning inside of orthotics and prosthetics is started to happen. There's been some people in the field for a long time that have already had those tools, but they weren't necessarily utilizing it for additive. So I think there's going to be, within the next few years, or maybe even sooner, more interesting tools that are designed specifically within the field. And you see some of these acquisitions that have happened by some of the larger players, Osier and some of these other ones buying up different smaller pieces of software. And as additive gets utilized more into that, the tools will have to expand more, right? I think what I see most about those tools are how do you make it easy for the clinician to use it? Because they're not always going to be someone who has an engineering background that came from using SolidWorks or, Fusion 360. And, you've seen people like Brent who have learned those skills along the way. But how do we make it easier and smoother for that to be adopted?
If you were look into your crystal ball, as far as, definitely, it's interesting that you mentioned the software stuff, and yours, we don't talk about this enough, but like, the company Equal buying up Vorum, Rodin, and TechMed all at the same time. I mean, that's a big portion of the digital tools that are available to us in the O&P industry. And now they're, part of this big kind of conglomerate that's giving Oser, Autobach, and some of the Hanger, a run for their money, because they are acquiring some of this stuff kind of at a grassroots level. But all that to say, Justin, what do you see? Because it seems like some of these bigger groups, I mean, you see Autobach, Hanger, dabbling in the multi-jet fusion side of things, but they're not necessarily making a push. And I know they're kind of working on stuff in the background, but a lot of the grassroots effort has come from small companies like what we're doing, what Quorum's doing, what Chris Baschek's doing with Point Designs, that sort of thing. So do you think it's, instead of the big companies kind of pushing down, it's actually the little companies showing what's possible, and the big companies are like, hey, we need to do something with it?
I think it's with any large company, there's risks that they have to measure, right? And I think that there's probably internal things that are happening that they, would love to show everybody. I think that they have to measure their risk of, checking as many boxes as possible before they really release, different devices and things that may be printed. But I very much agree with what you're saying, and I think that's where the larger companies have to pay attention to what's happening within your industry, right? Because you and some of the people that you mentioned are really pushing those boundaries, right? And I think that's what gets the attention, right? You see the development of what is possible, and I think larger companies will have more adoption of it. I think they're just very slow, and this happens with us here at HP quite a bit, right? We have to really assess the risk because you don't want something falling back on them that would be devastating, right? So I think they're moving quicker, and I think more things will come out, but it's really given the opportunity for, I find it extremely fascinating because it's rare that you see an industry where the smaller guy is really the forefront of what is happening, right? Usually they would have bought all of you by now, right?
Right.
And it's like, all right, this is what's going to happen. But it's amazing to see all the progress and how, and in my opinion, is moving very quickly. It's when you say years, it's like that. In retrospect, that's actually really fast.
Yeah.
So I very much agree. It's nice to see the smaller people pushing the boundaries.
So I guess, and I've got a question for you, Justin, and then yours, if you could follow up on it too. And this actually just came to me. The slowness of some of the big companies doesn't actually mean, and Justin, you're saying it, they're probably doing stuff internally and all that stuff. Is it possible that they're kind of stocking up on IP, intellectual property, to then come to market, essentially come to market with their product and maybe, push the innovation, I guess, that way? So they're not necessarily in it, but they're stocking up around this idea of intellectual property specifically. It could be lattice, could be socket design, could be software side of things. Is that something? I have no concept of even precedence for something like that.
Yeah, I mean, I wish I knew the full answer to that, right? Like, is it they're putting a lot of different patents inside of things? I'm not sure, right? I mean, I would imagine they're going to patent any device that's going to come out, right? No one wants to give anything away for free. But I don't know if they're trying to patent around it where no one else can do it, right? I think that's the advantage with it being digital, right? With this whole field, is that you have access to the same tools that they do, right? And everyone, it's not like you had to go spend $1 million for this piece of software, right? And on the digital side of it, it's very accessible, depending on the tools that you're using to create and design files. So I think that's upon the individual, right? And the creativity of the individual. I don't think it's possible to box out the advancements of what will happen, right? And thankfully, there's lots of people out there pushing forward for it.
What do you think, Joris? Do you think it's on these big companies? I mean, is it a intellectual property play where they come in and no, not possible? I have no idea. That's why I ask you.
No, I think so. Okay. Companies either have a process to develop intellectual property on an ongoing basis, right? Really large companies like IBM and companies like that do that, right? And also other companies, like companies I've worked at, they're really literally like a guy comes up to your desk and wants to know what you're working on, and they patent whatever they think they can patent, right? And that's like a parallel process. It doesn't really, it operates usually in addition to or next to kind of the strategy element, the driving strategy of the business, right? And I think 3D printing for these large companies, is on the radar and they're engaging with it. But for them to have a meaningful impact in it, and I agree completely what was said before, is like for them to have a meaningful, what Justin said, for them to have a meaningful impact in it, at the same time not fail at it, is, for me, in an internal way, is really deciding whether they will engage in this, right? Can Jane successfully launch a 3D printing product that will make her a career, will make her business unit director guys happy, and will then make meaningful impact on the bottom line of a large company, right? Without making everybody look like they have egg on their face and without getting them sued or whatever, right? We have to remember that there's things that happen, like Dow, for example, had really big problems with breast implants failing and all this, and actually kind of destroyed the company. And that's the things that these guys are thinking about. They're thinking of a lot of other moving parts at the same time. And they don't want to destroy the value generated by the 100,000 people or whatever by some really cool project that doesn't really have meaningful revenue or revenue growth for the firm. So they will be slower, and there's a diseconomies of scale of these large businesses that means that they will be slower to decide and go ahead with things. And a lot of times it's just not big enough. I've had issues, for example, in 3D printing where I've said to companies like, hey, you should buy this business. It's a really great $25 million business. It's growing very quickly, and I think it's really going to add to your bottom line. And they really don't think it's meaningful because they're used to doing several $100 million acquisitions. And for them, this thing wouldn't really be worth the trouble. So they'd rather wait until it's much bigger. And I'm saying, no, if you then now buy these 5 different companies, this is going to be really wonderful and really going to allow you to control the space. But then it's still not meaningful for them, So they just have a really different kind of scorecard than other companies. And that really is driving this thing. And then we see this in orthopedic implants as well. That there it's ingrained. All the risk taking is done by the startups. And once they're big enough, once they've reached a certain hurdle, but don't have the several $100 million in cash needed to take it to distribution and maybe even approval, then they get snapped up by the bigger companies. That's kind of ingrained in that industry. I think we're going to see that in a lot more industries as well, where the risk taking is done by the smaller ones. They get a premium when they get bought, and the larger company just sits back and tries to refine its processes of making money. Sorry about the long answer.
No, I mean, that's a great take. And I mean, I think that should, for our listeners, that are probably, well, I'm ignorant when it comes to that sort of thing. I like to give everything away. And sometimes that's not a good thing. But, I always fear, and that's one of the reasons why I push so much out, is like, I don't want these companies to box any of the small guys in with, some sort of intellectual property claim, so to speak, where it will hinder the progress that has already been made, specifically in orthotics and prosthetics. We're just too small for that. And so I think that's great news for a lot of people. And my encouragement then to people is, hey, keep on pushing forward, and maybe one day you'll end up with a payday or a part of a bigger company that can even push it further than it ever has been before.
I think also the point is that if we see like the true value in additive has been unlocked by startups, and I know we keep talking about this, but Invisalign, for example, has a market cap of $20 billion, and it's a $4 billion revenue company. We mentioned in the last podcast as well. It's $4 billion revenue, and the whole 3D printing industry is $15 billion. And that's just one application by one really tenacious startup that really unlocked that. And they're really focused on that in a way that a larger company really can't do that. They can unlock businesses maybe for someone else, but like you saw large companies make servers, but not a lot of the large companies made the really big websites that dominate our online life right now. A lot of them are made by startups. And, think of Sears, right? Sears is the best company in the world to use the internet. All they had to do was make a website and do everything else they were doing. They didn't have to change a thing, And Sears spectacularly failed, and a lot of companies like them, So a lot of times it's very difficult being a big company.
Yeah. So no, I mean, I think that's great. Well, Justin, we went into the weeds there for a second. What would you say to people, our listeners that are looking to get into digital manufacturing, or and now that you've had 4+ years looking and seeing how the landscape is changing, what would be some of the first what's a great first and second step for those people that are just either on the fence or are finally like, hey, I need to make a step because I see it's the future, but I don't know where to start.
Yeah. So where to start? You have to be digital, right? I mean, you have to start somewhere digitally. So, I mean, we've mentioned this both before. I mean, you have to start scanning, right? And I've seen you repeatedly say, pick a scanner. And, I think you can start cheaply, right? You can use an iPad depending on what you're trying to do. You don't have to have a $30,000 scanner to do it. Now, there's always going to be a difference in between what you did for $500 and what you did for a vast amount more money, right? But somewhere there's a measure in between of what is good enough. So scanning is obviously, first step, right? You got to get into scanning. As far as software, obviously if they're listening to this, they've been following you. And I think you've given plenty of advice on different software and where to get from, right? So, they can contact people like you as far as the digital side of designing. From our side, if they needed a custom tool, I'm not going to say there's no one on our team that is a certified orthotist or prosthetist that does the software side of it, right? You need those to be hand in hand, right? You are the expert in what you're doing. We can help you with the tools to get there, but we're not the expert in what needs to happen for the patient. And so we could create custom tools. There could be a lot of different avenues to start. But the first thing that you have to do is have a conversation, right? It could be with us over at HP. It could be with Brent, someone that you're seeing and following. And I feel like this field is very much like the additive field, that it's a community and a lot of people are very friendly and always willing to help. And I think that's the first step, is having those conversations with individuals. And you may start with me and then end up with a different person, but you're never going to get anywhere if you don't start the conversation.
And is there like an ideal customer for you? Or are you like, if you are this kind of business, totally talk to me? Or is it like, for example, if you're making devices, for example, if you're inventing devices, or if you need like a kind of phone replacement, are there people that say, if you have that problem or if you have that challenge in your product, then you need to put 3D printing like number one on your list of things to do?
I will talk to anyone. There are no dumb questions, as we like to say, right? And so it could be about anything, specifically to orthotics. Like, what are we looking for? If I'm focusing on just selling a piece of hardware, then I'm going to size that, the amount of production that you're going to do, right? And if you don't have enough devices that you're going to produce, then ideally I will say, I don't think that's the right fit now, right? And then, like I said before, connecting with someone that you can buy a lot of parts for the price of a printer, right? And when you look at it as a value chain throughout, as long as you're printing, I'm happy, right? If it's through a service bureau, it's still the use of the technology, and that grows it. And if you start with one device and all of a sudden you're like, this is working, and you're growing more and more, then there's the time to have that conversation of it's time to bring it in house. But if you were if we had a lower cost system, right, then you could expand more into the smaller practices. But typically you have to have 2 or 3 clinicians to start looking at it in order to just even produce the amount of devices. Or you have to be someone who's going to produce parts for other companies, right? Whether it's within the O&P field, if you don't have the quantity of devices that you can produce actively within your clinic. So it can play in a lot of different roles. It's just, do you want to take that step to fit the production that you have? Or do you have enough interest in doing it for other people in addition to yourself?
Okay, I think that's a good thing. And Another thing is like we have focus. I just noticed this now that we have focused the whole time on this TPU, soft, elastomeric materials, right? But there's also another thing that with like really fine assemblies and really complex parts and really low volume parts in kind of more rigid polyamide and other materials. That's also really something that people should really look at, right?
Absolutely, especially when you're doing prosthetic sockets, there's a large volume within our build envelope that is unoccupied, right? And when you want to validate the price of a part with a powder-based technology, whether it's ours or another one, the more parts that you produce within that build envelope, the cheaper the price is, right? And so if you have other auxiliary pieces of hardware that can fill up inside of that build volume, it's only going to drive down the cost of all of the devices that are inside, but particularly the large volume ones that occupy a large amount of space within a print volume. And the reason that is to kind of quickly and simply explain that is that there's X amount of fresh powder going into any powder-based technology, which has a cost, right? We all recycle whatever we don't use, and that gets mixed in with fresh material. But that fresh material has to be accounted for each job, right? And let's say a build volume costs you $200 in fresh powder. If I only have one device in it, I'm already starting at a $200 cost. If I have more devices in that print envelope, then it starts to go down, right? Because we're going to spread out the cost of that initial fresh powder across the build envelope and to the amount of parts that are within the build chamber.
Yeah, I think that's a really good point as well. You have to have the volume, and not just sometimes, but all the time, because you're going to have to free up operator space. It's going to take up a lot of like square footage in your office, and you're going to have to maybe get post-processing equipment as well. So you have to have that really high. Well, if you have really high utilization, it's a really, really fantastic technology. And if it's kind of more ebb and flow, then yeah, again, maybe partner up with somebody or partner up or buy a system together or something like that to really offset that cost. And Justin, like if we look forward, like are there other new emerging things where you're like, OMP then, where you're like, oh my God, I would love to get, like, for example, one thing we're all about in additive is grips, right? So are you really excited about things like finger grips, for example, for prosthetic stuff like that? Or are there other areas where you're very enthusiastic about them?
Yeah, I mean, grips are definitely, that when we look at cost apart, like we were just kind of talking about when you start talking about grips or even pediatric devices, those start to become a great fit, right? Because the size and the amount of parts that you can fit into the technology start to make it way more cost effective. So for the customer themselves, when you're dealing with the smaller devices or even parts, the better that will be. As far as development that I think is interesting, I don't think there's anything out there purchasable at the moment, is like embedding electronics within the parts, right? Can we as like HP start to print fluids that can conduct the electricity to make some of those movements, right? And embed that inside of it, or even sensors inside the devices that can give feedback to the clinician about the patient. To me, that's very interesting, and I think it's highly possible. And so, pushing that boundary, if we're looking at all the, avoiding all the other challenges that we need to work on as far as like reimbursement and more adoption, but looking forward, I would say sensors and electronics throughout the devices being printed in are to me where I feel like the next step we need to go is.
Yeah, I think that's a totally fantastic kind of assessment. I love, anything of that idea, like selectively applying your binary agent, like to change properties or to get something magnetic, weakly magnetic, or conductive. I think that's absolutely fantastic. Super futuristic stuff, and I really, really hope that becomes much more commonplace. But Justin, thank you so much for your deep dives. I think this is really, really helpful for a lot of people, I think, coming to grips with additive. Thank you so much for being on the show today. I think this is really valuable help for a lot of people trying to really get a deeper understanding of what additive 3D printing could bring to OMP. So thank you so much for being here today, Justin.
Yes, thanks for inviting me, and please have me back in the future. And I look forward to seeing both of you on my podcast.
Okay, yeah, super cool, man, super cool. We'd love to come, and we'd love to have you back. And yeah, that'd be great. That'd be great. And yeah, Brent, as always, thank you for being here as well today.
This was great, yeah, and we didn't hop into Justin's journey much on how he got in there, so yeah, we're due for another episode, for school. And there's a lot of people interested in like the application engineering side, not necessarily prosthetics, but how to make a difference in somebody's life. And there's so many of these little pockets of engineering that, yes, you might be working on automotive side of things, but you also may be doing something like prosthetic research and how to make better prostheses. And so I think that really resonates with a lot of people as they're going on their kind of job journey.
Yeah, thank you. Thanks, everyone. We hope you really enjoyed this episode of the Prosthetics and Orthotics podcast. Have a great day.